Today we're talking about sugars, so specifically carbohydrates, and we'll also talk about some other things that can happen on the cell surface and ways these can also attach to proteins. So just so you know, sugars are not my favorite. I always thought they had really dumb names. Also, the natural form of amino acids is the L form. The natural form of sugars is the D form. So for some reason, I was like, amino acids are amazing and sugars are not. But we're going to get through this together. So why are we studying them? They are actually really important. They do a variety of things, like they're the reason why blood types exist. They actually serve as a variety of different recognition molecules. They're important things. They also are going to be a major energy source for the cell. So they are useful, they are valuable, but if you hear any amount of like, in my voice, it's because this is just not my favorite. Also, we're going to start glycolysis next week, which is all about breaking down sugars. And ironically, I like that. We're also going to talk about the pentose phosphate pathway, but after exam 3. So we'll deal with that later. So I was trying to get into this. So from an old article from the American Chemical Society, they were talking about FODMAPs, or fermentable oligosaccharides, disaccharides, monosaccharides, and polyols. So what these are is these are a set of sugars that make really great food sources for a variety of different bacteria in your intestines. But what that means is patients that suffer from irritable bowel syndrome then have major problems with them a lot of times. So a lot of times what people will do is basically devise a diet that's really low in these foods and then add them back in slowly one by one to figure out which one causes the most issues. So notice that it's working usually with a nutritionist, so it's not a long-term diet solution. This is just trying to bring in another way to talk about sugars, another reason why they're important. So as far as carbohydrates go, the carbohydrates are hydrates of carbon. I know, amazing, right? They've got a general formula, and usually we'll be talking about carbons where you've got at least 3 carbons, oftentimes more than that. It is a really large category of organic molecules. Also, like I mentioned earlier, a major form of stored energy. We'll be talking about both starch and glycogen in a little bit. These also have really important structural roles. So that's perhaps to me one of the most interesting thing about carbohydrates is that we can use them for energy storage, but we can also use them as really nice structural things. And it works really well in both cases. You're also going to see that carbohydrates can coat proteins as well as lipids. So you're going to see this notion of glycoproteins and glycolipids. That glyco part tells you that there's a carbohydrate that's attached on there somewhere. We're going to focus mostly on those carbohydrates that are energy sources because we're going to be focusing a lot on glucose. When we get to glycolysis, which is coming up really soon, glycolysis is kind of the fundamental pathway in biochemistry. It's really well studied, and so we need to look at sugars before we can talk about how you break one of them down. Carbohydrates are classified into 3 main groups: monosaccharides, oligosaccharides, and polysaccharides. So somewhat similar before when we had those rounds of peptides and like how big is a peptide. We have the same general notion with now carbohydrates, where monosaccharides are going to be a single unit, can't be broken down into anything else, and still call it a carbohydrate under that category. Oligosaccharides, where you're going to have a few, somewhere between 2 and 10, and polysaccharides, where you have a lot of them. So again, there's going to be a nice thing with polysaccharides is polysaccharides usually have like hundreds of units. So usually there's a pretty big gap in between oligosaccharides and polysaccharides, but we'll look at that as we go along. And there's a lot of text here. So chemical features. Usually you've got a lot of asymmetrical or chiral centers. We're going to do a separate video on those chiral centers so that we can talk about those bit by bit. These can either be linear or ring structures. So when you start to see pictures of glucose, that can either be as a ring or it can be as a linear form. Both are accurate. We're going to get polymers through glycosidic bonds, which we'll also talk about here. You can also get multiple hydrogen bonds with water and other molecules. So these things are very hydrophilic. They are going to interact beautifully with water. And again, monosaccharides would be somewhere between usually 3 to 7 carbons. Oligosaccharides, like we said before, 2 to 10 monosaccharides. Disaccharides, which are very, very common. So we're going to, again, use that Greek prefix of di meaning two. And then polysaccharides will have a lot of them linked together. And we'll be spending more time on that glycosidic bond in a later video. So don't worry, we'll get to that. We're going to have two main sets here. We're going to have aldoses and ketoses. So here we're using the smallest version of a carbohydrate, looking at a 3-carbon carbohydrate. And so what you see on the left is glyceraldehyde. So this is the aldehyde function. So what you see highlighted in yellow is where it's getting that name from. So this is that throwback again to your organic chemistry and that aldehyde functional group. Then on the right, you have dihydroxyacetone. So here you again have that ketone. So that ketone then is what gives it a ketose. So a ketose is going to have that ketone functional group. It's how the aldehyde function. So that is going to give it more stereoisomers as we go along. And ketoses will have a ketone group. So starting to talk about aldoses, when we look at these basically start to form these really interesting trees. And what we can do with this is we can talk about stereocenters in here. So if you'll look, that one carbon that's highlighted in pink is going to maintain the same stereochemistry. And as we add additional carbons, we essentially add another stereocenter. So as we do that, every time we add a carbon, you're going to have another opportunity to have a different stereochemistry. So starting with D-glyceraldehyde, with only 3 carbons, we then, as we add another carbon to this, we then get 2 completely different options. Even though we're holding one of those carbons with the same stereocenter, that one highlighted in pink, since we've added one that's now highlighted in yellow, you see now we have 2 completely different carbohydrates. On one hand, we have D-erythrose. On the other hand, we have D-threose. So carbohydrates are going to have a lot of common names, part of also why I'm not a big fan, but that's okay. The nice thing is that we don't have to memorize these names. So then when we start to look at all the different varieties and complexities, every time you add another carbon, you're adding another stereocenter. So that's basically what's portrayed here, is as we add carbons, you add more and more possibilities for different kinds of sugars, for different kinds of carbohydrates. Taking a look at ketoses, we have that same general notion. When we look at numbering ketoses, you're going to start numbering from the end that's closer to the carbonyl carbon. In dihydroxyacetone, since it only has 3 carbons, and it's your center carbon that has the carbonyl, you'll notice that that one doesn't actually have, you could have numbered that one either way. So that one is symmetrical. But then as we start to add things, now is when our numbering comes into play. So as we move on to D-erythrulose, now what you'll notice is that now that the carbonyl carbon can be placed on one side or the other, now we can actually have a set of numbers that go along with this. And so now as we start to add stereocenters, every time we add another stereocenter, we add another set of potential differences. So what you'll notice here is that they're going ahead and picking one conformation of that carbon highlighted in pink. And then as we add this again, starts to tree and have a variety of different options as we go along.